In this video, we'll be talking about how to factor special polynomial forms. Now, hopefully you'll recall that 2 videos ago, which was the video for 0.3.3, we discussed special products. Using these, we actually can do some special factoring as well. So we can turn these around to get some special factoring formulas. For instance, our most important example is the difference of squares formula, which is u squared minus v squared. So we have a difference of 2 things squared. We can always factor that in this way. In a similar way, we can factor out perfect square trinomials and sum and differences of cubes. The perfect square trinomial, what we have here is, this is actually, if you look back to that section, we have u plus v squared, and turning the other formula around for the difference, it would be u minus v squared. So before we had the formulas kind of going this way, now we have them going this way. Of course, equality works both directions. Sum and difference of cubes, for this one is a little bit special. You can check this by foiling out, but what it's going to end up being is u plus v times u squared minus uv plus v squared. And here we swap the negatives, so the signs. Okay. So, for example, if we wanted to factor the following, what we could do is notice this, we could pull out 3 out of both of these. So first factor the common factor out. And then what we can do is we can actually notice that this is a difference of squares here. Namely, this is 3 times 1 squared minus 2x squared. And thus, we can factor it using our special factoring formula. 1 minus 2x, 1 plus 2x. And now that is fully factored. In a similar way, we could factor this that same way. Namely, we could factor this into x plus 2 minus y times x plus 2 plus y. And we could drop these parentheses here and have x plus 2 minus y, x plus 2 plus y. Here, if we notice that this is the same thing as 4x squared squared, and 81 is 9 squared. Then what we can do is we can actually factor this into 4x squared plus 9 and 4x squared minus 9. However, if you pay close attention to this, this is also a difference of squares. This is a sum of squares, which we can't do anything with, but this being a difference of squares, we can factor it the same way again. Namely, 4x squared is 2x times 2x, so 2x quantity squared. And that 9 is 3 squared, so we can factor this the following way. So let's go ahead and dig into these forms a bit more. Here, if we factor the following, we notice that this has the form x squared minus 2 times 5 times x times 5 plus 5 squared. These all fit in the correct spots to be able to use the special factoring formula that this is really x minus 5 quantity squared. In a similar way, this one, if we recognize that this is 4x squared, this is 2 times 4x. So that would be 8x, and so I have a 3 left over. But that works perfectly because this gives me a 3 squared here. then this works perfectly to be 4x plus 3 quantity squared using a factoring formula. Finally, using the formulas before, the formulas for difference of cubes, we can factor this as x minus, so recognizing this is actually 3 cubed here, what we actually get is this is x minus 3 times x squared plus x times 3 plus 3 squared. But we go ahead and we simplify down the second term just a little bit, and we have x squared plus 3x plus 9. Finally, here we can pull out a common factor of 3 first. So, 192 divided by 3, what is that? Well, 3 goes into 19, it goes into 18 perfectly, so that would be 6 times 3. 6 times 3 is 18. Subtract the 1, the 2 comes down. 3 times 4 is 12, and that gives me 12, so those gives me 0. So it's 64. And now I can factor this the same way I did before, except now it's a sum of cubes. So 3 times x plus 64 is, what? What is 64? 64 is 4 cubed. So this is 3 times x plus 4. Then we have x squared plus 4 times x, or x times 4. So let's go ahead and simplify because I've run out of room on my page. And then we have 4 squared, which would be 16. So hopefully that wasn't too fast. And now it's time for you to try an example. Go ahead and factor the following. And in the count of 3, I'll give you the answers. 1, 2, 3. So I only wrote out the factored forms for A, B, C, D, E, and F without solutions. Hopefully, based on the last example, this can be clear. And yeah, sorry, I just didn't have enough room to do all of them. For more practice factoring with these special factoring formulas, be sure to look at page A33 of the textbook and numbers 7 and 41 through 54. And in our next video, we'll get into the heart of the matter with factoring trinomials with binomial factors.